When we're talking about energies, it's helpful to have some terms to help us describe when energy is entering and leaving our system. And those two terms are going to be exo and endothermic. So looking at exothermic first, let me give the big picture on the definition and bring up the two examples that are listed here. Exothermic means that energy is leaving your system and going to the surroundings. You can remember that pretty easily by remembering that exothermic is because the energy is exiting your system. Exo, exiting. Now, if heat's exiting your system, there's a few ways that that can manifest. You could have heat being a product in a reaction, for example. If you light something on fire, the combustion reaction typically is going to have heat as a product. So combustion reactions are going to be exothermic reactions. Also, if heat's given off by the system in other ways, melting processes and heating processes, we could talk about all those sort of things as well. So if I have if I have water that boiled and made steam, as that steam is condensing and going from gas to liquid, that's going to be an exothermic process. Now, endothermic processes are ones that take in energy. Heat goes into the system, or I like to remember it by slurring the word a little bit. It's going into the system. End of the system. Endothermic. Now, in an endothermic process, we have a couple examples here as well. You could have heat used as a reactant in some sort of a reaction, or that heat's being taken in by the system, which may or may not be causing a change. It just depends what you're doing. So if I have evaporation, I have liquid water, it's picking up heat energy, and it's converting into gas phase. That would be an endothermic process. And here you can see those given graphically to help us get the idea across. If I have water as a gas, turning into water as a liquid, gas phase water is going to have a lot more energy. Remember all those videos we've seen of the gas phase water molecules or any other gas banging into each other. There's lots of kinetic energy there, right? Well, when they slow down and start sticking to each other, that kinetic energy had to go somewhere. It exited the system and went to its surroundings. In that case, the gas phase water has converted into liquid water. Delta E is going to be a negative sign. Enthalpy will be a negative sign, and we'll talk about enthalpy in a separate video. And this process would be an exothermic process. If we do the opposite, where we have liquid water evaporating, in order to make that happen, we have to put in heat energy. When we heat up the water, it's going to go into the gas phase. It now has more kinetic energy. To get that kinetic energy, we had to give it some energy in the first place. Delta E will be a positive sign. Same with enthalpy. Those will be endothermic processes. Now, the other thing that's important to realize, these are path-independent processes. If you're making the same transitions, but in a different order, it doesn't matter. The quantity of energy will still be the same. The sign on that energy will be opposite, but the size will be the same because you're talking about a path-independent process.